Hey everyone, welcome back. In this video, we're going to learn how to manufacture the container that we designed in our last video. All right, so we're first going to learn how to manufacture our lid here. And then once we're done with our setups 1 and 2 for our lid, we will then go ahead and learn how to manufacture our container base. All right, so let's come on over here, and where it says design, we're going to now come on over to a manufacturer. Okay, I am going to close my data panel. All right, so hold down shift in your mouse wheel and let's rotate our part and flip it over. So this is the part we're going to be machining for our first setup. We're going to hollow this out and remove the material around the sides. So to do that, let's go start a new setup. So the first thing we need to do when machining a part is we need to set up our work coordinate system. So I'm going to kind of situate our part so it kind of looks like this, kind of like you'd see it as if the part was in our machine, okay, and you were looking at it right in front of you. So our work coordinate system essentially uh, tells our machine which way is up, down, left, right, and all that good stuff, okay? But it only knows X, Y, and Z. So let's go ahead now and select this back left corner, okay? Because when you're starting off with a work coordinate system, it's customary to use the back left corner. Not always, but in this situation, and in a lot of situations, we'll use the back left corner. But now we need to make sure that our X here, our positive X, is pointing to the right, not to the left. And we need to make sure our positive Y here is pointing away from us. Okay, and our positive Z is pointing up, which it's already doing so. All right, so we got to change some things here. So I'm gonna come on over here now, and let's go over here to model orientation, and let's select our X and Y axes here. So I'm gonna just kind of click there. Okay, I'm saying this is my X direction. Okay, and I'm going to go ahead now and flip my Y. Okay, and that looks good. However, we need to come on over here now and do stock box point and click back there. Okay, and that is the correct orientation, right? We need our positive X going to the right. We need our positive Y going away from us and our positive Z going up. Okay, fool around with these until you get it right. All right, it may take a little practice. Okay, now we need to establish our stock size. This is the size of material we're going to start with, our block of metal. What is our block of metal size, right? So in this case, we're going to go over here. We're going to use a fixed size box, and we're going to make its X width here 3 inches, its depth 3 inches. So type in 3, 3, and we want it centered, and we want it centered. And then for our Z, our metal bar thickness, it has a thickness of not 0.5 but 0.75. Okay, and for our model position, we don't want it centered, we want it offset from positive Z. Okay, and we want it offset 0.02 inches, and this 0.02 inches, keep that in mind for later, because that 0.02 inches, that's the thickness we're going to face off on our first operation. Okay, and we're also going to have to remember this 0.02 thickness when we start our second setup later. Okay. All right, I'm going to go ahead and click OK. All right, I'm going to just come over here real quick and change this. Let's go here. I'm just going to click on it, and we're going to call it setup 1 because it's our first setup. Okay, and hit enter. I'm going to come on over here and I'm going to hit save before I get any farther. Okay. All right, so remember this part, we are going to make this part in our class. So it's imperative that you enter everything correctly. So our first operation is going to be our facing operation. So we're going to come on up to 2D and we're going to start a facing operation, okay? And the first thing we want to do is to come on over here, and you should have installed your container tool library, okay? So now, all right, what we want to select is our 2.5 inch face mill. So let's go ahead and select that guy. All right, and we are going to use a spindle speed of 4,000 RPMs, okay, and a cutting feed rate of 20 inches per minute. That's the speed of our tool cutting through the material, right? Okay, all these other values for now are fine. Okay, make sure your coolant says flood, and your coolant should say flood the entire video. And if I forget, make sure it says flood. Okay. All right. Now moving on. Okay, for our geometry, we want to cut down to the top of our part. So I'm going to click there. Okay. And then we're going to come on over now to passes. Okay. And for our pass extension, we're going to set this 1 inch. That means our tool path is going to extend 1 inch out past our part. And we're going to widen the tool path by 0.25, a quarter of an inch. So this will widen our tool path to make sure that the entire surface gets machined. Okay. Now go ahead and select OK. All right. Now let's go ahead and simulate it real quick. And you should always be pausing these videos and simulating them yourselves to make sure everything looks good. Okay. I'm going to make sure stock is checked, and I'm going to change my view here. So this right here, this little thickness, that represents the 0.02 inches that we set our part below the top of our stock. Okay. And that's the amount we're taking off. So we can go ahead and hit play, and we can watch that 0.02 inches of thickness get cut off. Okay. And looks good. Okay. All right, so now let's go ahead and start our next operation. We're going to come up to 2D, and we're going to do a 2D adaptive clearing. Okay, and we're going to come over here, and we're going to select a different tool, come into our container tool library, and we're going to use a 3 flute 3/8 end mill. Okay, so let's go ahead and select that guy. All right, and now make sure coolant is set to flood. Okay, for our spindle speed, we're going to use a spindle speed of 5,000 RPMs and a cutting feed rate of 20. Keep in mind, I'm keeping these values a little bit conservative for now. Okay, as we make more parts, we'll speed things up a bit. All right, all the other default values are fine. For geometry now, okay, I want to click on this guy right here. Okay, basically the bottom of our chamfer, this, not this line, but the one above it. This guy right here. Okay. And you're probably thinking, oh, Mr. Fuller, it's only going to cut that deep. Well, we can adjust that. We're going to come over to heights. We're going to come to, let's go with selection. And we're going to set our bottom now to this bottom height. And we're going to offset it minus 0.02 inches. So it goes down a little bit more. Okay. And then for our passes tab, we're going to set our optimal load now to 0.1, not 0.15. Okay, remember optimal load is your step over. It's basically the percentage of the amount of tool that's engaged with the material when it's cutting. And we always want to keep it around 20% of our tool. Okay, so 0.1 is a pretty close to that. Okay, for stock to leave, you make sure you check stock to leave. And remember, adaptive clearing is a roughing strategy. So we want to leave 0.02 inches here along the walls and the floors. Okay, so we're going to go ahead, and in this case there is no floors, but that's okay. It knows this, so we'll leave 0.02 material left, okay, along the walls of our lid here. And when you're done, go ahead and select OK. Okay, and this one I do want to simulate it real quick. So hopefully you have something that looks like this. And notice now it's going to cut, okay, around the side of it. Okay, and I'm going to simulate it real quick. And I'm not going to turn on my stock so you guys can see. And if you can see it, it's coming down to the bottom of our part. Okay, and it's coming around, and it's leaving 0.02 inches on the side of or walls of our part. Okay, all right. I'm going to go ahead and close that. Okay, now let's start our next operation. So we're going to come on over here. We're going to do a 2D, and in this case, we're now going to select a 2D pocket. Okay, we're going to use the same tool as before, 3/8 flat end mill. We're going to set our coolant to flood, and we're going to use the same spindle speed as before, 5,000 RPMs, and a cutting feed rate of 20. Okay, and this time we are going to create a plunge or ramp sort of tool paths, because it's a pocket. It's got to come down into our solid here and kind of use this sort of helical or spiral tool path to come into our part. And so we're going to set that feed rate, okay, at 10. All right, and then for our geometry, we just want to select the inside of our pocket, right? And for our heights, we're good. For our passes, okay, um, same thing. Maximum step over, we're going to use zero point 0.1 like we did last time, okay? And we're going to leave stock to leave. Again, we're going to leave 0.02 inches along the walls, okay, and the floors of our pocket, all right? And that is it for this toolpath. Let's go ahead now and select OK. All right, so we are done with our roughing passes, okay? So please simulate this before you move on, okay? But I am now going to move on with our finishing passes because we are done with our roughing strategy. We came in and we moved a lot of material, and now we are going to clean things up. All right, so let's come over to 2D, and whenever you do a finishing pass, most of the time you're going to be doing a 2D contour, all right? So we're going to stick with the same tool, 3/8 flat end mill. Make sure coolant is set to flood. And this time, though, we're going to slow things down a bit. We're going to use a 3000 RPM, okay, spindle speed, all right? And we're going to slow down our feed rate as well. We're going to use a 15 inches per minute feed rate, okay? All of our other default values are fine. Let's come on over to geometry. We're going to select this guy because we want to remove that 0.02 inches along the outside or perimeter of our wall. Okay, that stock material we left behind. Okay, and for our heights, once again, let's just go to selection and we're going to select the bottom. Okay, and for our passes, all of our default values here are looking good. Okay, let's go ahead and hit OK. Okay, so we're going to come in and we're going to clean off that 0.02 inches of material left on the outer edges of our walls here. All right, now we got to do one more, okay, finishing pass with our 2D contour. So let's come on over here and do one more 2D contour for this operation. Okay, same feeds and speeds as before, same tool, 3/8 flat end mill, flood. Okay, we want our spindle speed to be 3000, feed rate to be 15. Okay, but this time for our geometry now, we're going to select the inside of our pocket again. Okay, and for our passes tab, all right, we want to change some things here now because we got to remove the material along the floors, that 0.02 inches of stock we left on our floor of our lid here. So to do that, we're going to come over to multiple finishing passes. We're going to set our multiple finishing passes to 4 now, and we're going to change our step over to 0.3. Remember, our tool is 3/8 or 0.375. So because we're only removing a small amount of material, we can have a high step over, okay? Because our tool is only cutting a thin amount, a 0.02 thickness amount of material. So we can use a bigger step over in this case, all right? Everything else looks good. All right, all of our default values, let's go ahead and select OK. Okay, so this simulation will come along, remove the 0.02 inches of stock we left on our walls, on our inner walls, and on our floor. Okay. All right, and that, folks, concludes our first setup for our container lid here. So when you're done and you want to simulate everything, and make sure you do so, okay, come on over here and go down to simulate. Please make sure your machining time is around 8 minutes and 44 seconds, if not exactly. It should pretty much be the same, okay? If you have something different, please check with me, okay? Or don't post-process or go machine or mill your part until you are 100% certain that you've done everything correctly, okay? Simulate everything, all right? Make sure you show your stock and run the whole thing and check it out, okay? All right, in many instances, when we go to do a second setup, we're just going to come on up here to setup and start a new setup. But in our case, we're not going to do this. So let's go ahead now and open up our data panel. All right, we're going to start a new design for our second setup. So we're going to do a new design, and we're going to go ahead now and save it as lid setup 2. Okay, and we're going to go ahead now and save it. All right. And what we're going to do now is we're going to go ahead and upload a file. So there's the Kurt Weiss file that you were supposed to download, and we're going to go ahead now and upload that file to our computer. So we're going to select upload. I'm going to select the files. Okay. And wherever you saved it on your computer, go ahead and locate it and then hit open and then upload. Okay. And once it's complete, go ahead and X out of there. Okay, and I'm going to right click now on this guy. Okay, and I want to insert it into my current design, my new file I just created. Okay, and I'm just going to kind of rotate it over so it's about like that. Hit OK. Okay, and now I'm going to take my lid that I just made. I'm going to right click here and I'm going to go ahead now and insert it into current design. Okay, so for our second setup now. But now I want to move my lid so that it's sort of orientated in a manner that it looks like it's going to go into my soft jaws here. And so notice I have these soft jaws in our vise. These jaws are a custom machined fixture that I made for this project, okay, on our Kurt vise. Okay, so, and I want my text to be sort of horizontal and in line with my soft jaws. So I'm going to rotate it around another 90 degrees here. So hopefully you got something that looks kind of like this. I'm going to hit OK. All right, and now we want to assemble it. So when we assemble something in Fusion 360, we come on up to assemble and you go down to joint, and I'm going to make sure it's a rigid joint in this case so it doesn't move. Okay, and I'm going to zoom in, and when you assemble something with a rigid joint, you got to think about which points match up with the other points. So for example, if I click here, this guy right there, I would want my part to be in there. And so where's that going to match up on my lid of my container? Well, if you guessed right here, okay, right there, you're correct. Okay, and that's exactly how we want it. So do that, please, and select OK. Okay, and so now we have a rigid joint. Our part is in our vise, which is exactly how we want it. Okay, so if you have trouble getting it into your soft jaws, like orientated as such, please let me know. I will help you out. All right, and I'm going to go ahead and save this now, and I realize I didn't save it in the right location, so I'm going to do a save as, and not sim files. I want to go to container 2. Okay, and so lid setup 2, I'm going to save it there. Okay, now we should see it pop up here. Okay, so the difference between these two files is one's just the vise and the soft jaws. This one is the vise and the soft jaws and our container lid here. All right, assembled. All right, so hopefully you got everything placed together nicely in our vise. I'm going to go ahead now and close my data panel. All right, and we're going to start a new setup. All right, so now the first thing we want to do in our setup, let's go ahead and identify the model, the part that we want to machine, which is our lid, right? So we're going to click there. Okay, for our orientation now, we're going to come on down and let's go ahead and select our, let's see here, our X and Y axes. So I want that to be my X. Okay, and for our Y, right, let's go ahead and make that our Y. Okay, and then let's do, for this guy, let's do selected point. And we're going to select our hole on our soft jaw right here. Okay, and now that's exactly how we want it. Now imagine there are vices in our machine. Okay, we want our positive X going to our right, our positive Y going away from us, and our positive Z going up. Okay, and we want it exactly in the middle of our hole. And when we go to get our G54, when we go to set up our G54 work offsets, we're gonna probe this hole for our X and Y, and then we're gonna probe the surface of our soft jaws, okay, here for our Z. All right, and we're good to go. All right, so now we got to set up our stock. Okay, and so for our stock, we're going to come over here to fixed size box. Remember, it's 3 inches by 3 inches centered, but our Z this time is a little bit different. All right, so our Z, if you recall, we faced off 0.02 inches off the top of our first setup when we first did our first facing operation. So instead of 0.75, we're going to do 0.73, right? Because just to review, we shaved off that 0.02 inches with our first facing operation. So it's a little less thick than it was before. And for our model position, we're going to offset it from minus Z 0 inches. Okay. And so I'm going to hit OK now, and I want to sort of zoom in here because this thickness right here, okay, we still have to remove this top portion, all right? So, and that's going to be pretty much our second setup, all right? We're going to remove this top material. We're going to create our chamfer and engrave our text. So now I'm going to go ahead and I'm going to rename that as our second setup here. Okay, and I'm going to start my first toolpath operation. So I'm going to come up here to 2D and let's do a facing operation. Okay, let's select our tool. Come over here to our container tool library. Let's select our face mill that we've been using. Select, make sure it's selected as tool number 1, flood, and we're going to set our spindle speed here to 4,000 and our feed rate here to 20. Okay, and all the other default values are fine. For our geometry now, we're going to select, once again, the top of our part. We want to face down all the way to the bottom. Okay. And then for our heights tab, we're good there. For our passes tab, let's set our pass extension now to 1 inch. So our face mill will extend 1 inch our toolpath will go 1 inch further past our part. And for our stock offset, we're going to widen it 0.25 inches so we get the entire surface of our part in stock material. Okay, but now, unlike last time, we got to check multiple depths. We have a lot of material to remove, and we just can't remove it in one big pass, right? So we're going to do our step down now of 0.05. Okay, and we're not going to leave any stock, and so we're going to go ahead now, and we're good. Let's go ahead and select OK. All right, and there's our toolpath. Let's go ahead and simulate it real quick and show stock. I'm going to speed things up, and you can see, okay, this is 0.05. That's our step down distance right there. Okay, and I'm going to just speed things up, and you can see it move that material all the way down to the top of our part. Let's go ahead now and hit close and start our next toolpath. And for our next toolpath, we want to go ahead and make this chamfer on the outside of our part. So we're going to come up to 2D, and you can do a 2D chamfer. I like to make my chamfers with a 2D contour. I feel like there's more options available, so go ahead now and select a 2D contour. Okay, and we're going to change our tool now, and we are going to select our chamfer mill here, tool number 9. Okay, it's got that sharp tip point here. Let's go ahead and select that guy. Set our coolant to flood. Okay, we're going to use a spindle speed of 3,000. Okay, and we're going to use a cutting feed right now of 15 inches per minute. Okay, and for all the other default values are good. Let's go ahead and for our geometry now. And for our geometry tab here, let's go ahead and select the bottom contour line of our chamfer, not the top, but the bottom here. Okay, and our heights tab is good. For our passes now, make sure the chamfer box is checked, and we want to do a chamfer tip offset of 0.02 inches. What that's going to do is it's going to take that pointy tip of our tool and it's going to move it just slightly 0.02 inches down below our chamfer edge here, below this blue line. Okay, let's go ahead and hit OK. All right, that looks pretty good. And I want to show you guys real quick. I'm going to simulate it so you can see what that chamfer tip offset did. Okay, and if you look carefully, you can see that our tip is just slightly below the chamfer edge there. Okay, I'm going to close that out. Let's now go ahead and do our last toolpath. All right, so we're going to come on over here to 2D and we're going to select trace. Where is the trace? There it is. All right, and we're going to use the same tool we used before. Make sure flood is on. Same spindle speed, same cutting feed rate, 15 inches per minute. Okay, all the other default values are good, but for our geometry now, we got to come in and we got to select our text. And it's important that you select the top of your text, not down here, but the top of your text, because we're going to specify the depth of our cut here in a second. how deep our tool is going to engrave. So select the top of your text and don't forget the middle of those O's, A's, and E's. And gosh darn it, I just made a mistake. So you can click on it if you make a mistake and hit X or trash. There you go. And then click there, click there. And there. Okay. And we're good. You've got all your text, hopefully. You've selected all your text for your geometry now. Your heights are fine for passes now. This is important. For axial offset, this will specify how deep we want to engrave. And we're going to engrave a minus 0.01 inches. Okay. So everything else, our chamfer can be checked. That's fine. 0, 0 here. We're going to go ahead now and select OK. And you can see that it put it about 0.01 inches below our part. And because our chamfer is a little wide here, it's going to come out pretty good. It should. Okay, keep in mind I've made all these parts many times before I make these videos, at least most of the time. All right. Okay, and that is it. That is you should have a face, 2D contour, and a trace option for your second setup. Okay. And when you're done, please click on your second setup and please simulate it. When you are done, you should hopefully have a total machining time of about 5 minutes. It's a short one. Okay. If you don't have 5 minutes and 37 seconds, please double check everything for this setup. Okay. All right. That'll do it for this lid, for manufacturing the lid. All right. Stay tuned, and we're going to learn how to manufacture the container base. All right, here coming up. Thanks for watching, and we'll see you next time.